finish up our maps project to provide the product, the final product that we need in order to compile the information found on these three graphs. I'm going to be going through this data table that we started in notes a long time ago, and you will need to know what landforms and events are evidence of each type of boundary. The next thing that you're going to do is get a new plate boundary map and highlight one good choice for each type of boundary. And I'm going to go through, give you the evidence, and show you some examples on maps. So the first one is continental plates moving away from each other as divergent. You're going to see shallow earthquakes, inland seas or lakes, volcanoes, and rift valleys. So this right here, if I can drag it over, if it does that for me. This here is an example of a rift valley. This is Africa, this is Saudi Arabia, I think. But we have shallow earthquakes. We've got some volcanoes, more down here into Ethiopia. And we've got a very shallow inland sea happening. Evidence of a continental divergent boundary. Next, continental convergent, where two continents are colliding. We see shallow or mid-depth earthquakes. We see very high mountains with very few earthquakes. And so let me get this going over here. Doing it this way so you don't have to read my writing. Here we have, this is our plate boundary right here. This is India, this is Asia. We have shallow or mid-deep earthquakes. We have very high mountains from the topography. And we have very, very few volcanoes, if any volcanoes at all. Next boundary type. Transform boundaries, apologize for the yellow here, but transform boundaries can either be in a continent, two continental plates, continental or oceanic. It can even be two oceanic plates. But a transform boundary, we're going to see shallow earthquakes. There might be low mountains. There might be a few volcanoes. Transform faults are not that interesting, honestly. I was at the San Andreas Fault this summer and didn't see anything. So, so this is the San Andreas Fault here. This is Baja. But we have shallow earthquakes, lots of shallow earthquakes, few volcanoes, and the brown bits here are kind of mountains, not a whole lot visually to see there. The next type of boundary, my computer's the slowest one in the world. Write applesauce on the back of your paper if you're sticking with me. Extra credit. Oceanic convergent, two ocean plates coming together. We have deep earthquakes, we have island arcs, we have lots of volcanoes, deep ocean trenches on one side, shallow seas on the other. Lots of stuff going on here with this. So this is an oceanic convergent plate. We have lots and lots of deep earthquakes. Here's the boundary. Deep earthquakes. We have volcanoes. And over here with the topography, this is interesting. Right here, the purple, this is the darkest, deepest that it goes. We have real deep on this side, deepest right there at the boundary itself, and then shallow seas. This is the formation of an island arc, and those volcanoes that you see there are going to erupt and become islands of volcanic islands. But this happens many different places. Next, we have oceanic divergent, where two oceanic plates are moving away from each other. We have shallow earthquakes, a few volcanoes, we have mid-ocean ridges or ocean floor mountains. So what we have here, page 9, this document, by the way, is in Schoology. So here we have the mid-ocean ridge. There's Africa, here's South America coming down. We have very shallow earthquakes, not a whole lot for volcanic activity. But right here in the middle, this light blue is shallow water, and it's shallow water because we have a mountain chain under there. We have huge mountains coming up from this mid-Atlantic ridge right there. This down here too, we haven't worked with this map, but red here is young and blue is old. So you see that the young ocean floor is being made in the middle, and as it gets to the boundaries, it's going to subduct and go down and be destroyed. Write sugar plums on the back of your paper if you're still with me. Extra credit. Last, oceanic continental convergent, where we have a continent and an ocean colliding. Here we have deep earthquakes because of the subduction zone. We have lots of volcanoes, we have mountains, and we have ocean trenches that are near the coast. Page 4. Here we have page 4, please, not page 2. There we go. Here we have the western coast of South America. Come on. Where do I want to be? I want to be down there. Okay, I'll be satisfied. Here's the boundary. We have deep, deep earthquakes, and the farther inland they are, the deeper they get because that plate's going in and subducting and moving farther and farther. This ocean plate's moving farther and farther to the east and deeper under. We have volcanoes, lots of volcanoes in there. And then looking here at the topography, the geography, we have these high mountains. These are the Andes Mountains, some of the highest in the world. And then right at the edge of the cliff here, we've got this deep purple here. That's the deep ocean trench. That's the deepest part in the ocean. So we're right on ocean, deep, and then steep mountains right on the coast. And over here, looking here, we've got the older here is being subsumed. It's being subducted under the continent and disappearing. So you will be responsible for finding specific examples, the best examples of these types of boundaries on the 4th map. And then on notebook paper, you will have to provide evidence for why you have chosen those locations. Write pineapple, and that's 3 things for extra credit. If you're still with me, have a good night.